We're at the PROMATION LM400. This is the latest in the line of laser markers. This is the high end, and I'm joined by Josh Christofferson. Nice to see you, Josh.
Nice to see you too, Trevor.
So tell us a bit about this LM400. What are the key features of this machine?
So the key feature of this machine is its speed capability. We've got the laser head mounted to an X-axis, and we've got the PCB carriage mounted to the Y-axis, which allows us to move both simultaneously. In the past, we've carried the PCB on a 2-axis gantry, and that slowed us down just a little bit. So now we're moving about 10% faster.
10% faster, yeah. And it's got quite a large board capacity. What's the maximum size that you can accommodate in here?
18-inch wide by 20-inch long for this model.
So that really accommodates all your large backplanes, or it could be, maybe 10 up in a tray or something like that.
Yes. Yeah, we see as many as 20 to 40 PCBs in an array, which of course allows us to mark multiple barcode images at the same time without having to move to each individual location.
Right. Okay. So that's good. So you've got quite a big field of view of the laser itself. Yes.
Yes, that's correct. The laser has a 110 millimeter squared field of view, and this allows us to mark as small as a 2.5 millimeter squared 2D barcode. With about 6 to 8 alphanumeric characters in it.
Okay, so basically anything that's within that field of view you could do. So you could do 2 barcodes at once, for example.
That's absolutely correct. We could do 2 barcodes at once. We could do as many barcodes at once as we could fit in that 110 millimeter squared area, yes.
So let's talk about the laser source. It's a CO2 laser that is mounted above here, and I see it. You also have a laser inspection unit at the side, because the problem with CO2 lasers is they do degrade a little bit over time.
Yes, that's correct. So another new feature about this machine is our ability to monitor the actual wattage that the laser is pushing out. So this 12-watt laser, over time, as you said, can degrade. And so we've got a subroutine built in where basically the laser head moves over a specific device that measures the actual wattage coming out.
Right. But you get a fair life span out of it before we get to that point, correct?
That's correct. Most of our customers see about an 8-year lifespan.
That's quite significant. Now, you have a red filter on here, but I believe you can accommodate for different board colors and board types.
That's correct. So the red light is standard. This particular machine has 4 colors. Now we're able to go red, green, blue, and white. And the idea is that if we had a red PCB, for example, right now with a red backlight, it would be very, very difficult for the scanner to actually read the mark. What it would see would be basically like a white blur. So selecting one of the other colors allows us to neutralize that issue that we're having with contrast. That's the idea.
Okay. So what sort of cycle time do we get?
Cycle time is, of course, relative to the process. At the base level, it takes on average about a second to just under 1 second to move and then mark a location. This depends, of course, on the beam intensity and the mark size, but again, on average, less than a second. Now, when we start adding fiducial recognition points, it can take about 2 seconds per fiducial point. When we start adding, a PCB flip cycle like the machine just did, of course, we have to pull it out from underneath the laser head and flip it. That can add another second or so to the process. And then to verify a mark takes just under a second. So, anywhere from under 1 second per move and mark to under 3 seconds per move and mark, depending on how many features we want to use as part of our model recipe. Right.
But you can mark here, flip it, and mark a second board, and then move it offline to get verified in the second unit here.
Yes. Another new product that we're showing this year is our automatic scanning conveyor, which we've paired with this machine. Besides the 10% decrease in cycle time that we're seeing from the simultaneous gantry movement nature of this machine, as you said, we can also scan the marks that we've created in a secondary process simultaneously. So this machine, in this case, would be dedicated to the marking process, as I said before, taking just under 1 second, whereas the machine downstream from it can scan the top and the bottom side without needing to flip the board, and each one of those locations takes under a second. So now you're getting, 50% decrease in cycle time, still only using 1 laser marker.
Really? That's useful. So that typically sits beside the laser marker, but it probably could be moved further down the line if necessary.
Yeah, I mean, you could move it further down the line. Part of the nature of what we're doing here, though, is that we want to be able to capture that information as soon as possible, send it, to a factory MES, for example, but also validate that the mark is of a good quality. This machine actually features a scanner that's capable of grading the mark, which I know is important to some of our customers, and it's also, important information to be storing on the factory server, so that they can ensure that their products out in the field are going to be able to be read years down the line if need be.
Right. Okay, great. So I noticed you've got quite an elaborate software interface here. Tell us some of the features of that.
Yeah, the software interface is great. With this software interface, we have access to many variables that we can use to create our data string. So people always ask me, how do we generate the barcode? Is that something that our factory server has to supply your machine? The answer is yes and no. You don't have to supply that information. You can if you would like to, if that's the preferred way to handle it. However, we can create just about any combination of variables that you would need to create a unique identifier for just about any product. And not to go on forever, but basically you've got several indexing counters. Time date stamps are very big. Variables that allow us to copy codes or portions of codes and apply them as text, maybe. Human legible items, things like that. I know for bottom side marking, when we flip, it's very important that we don't index the counter. If we're copying a mark from the top side, we need it to be identical on the bottom side of the same PCB. Right. So we've got variables that handle that. And then we're also able to make adjustments to indexing algorithms. So for example, if you want to count hexadecimal or in an alphanumeric fashion, at the time of order, we would want to understand that, but we can create variables that allow you to do that as well.
Oh, very flexible machine. Josh, I want to thank you for showing that to us today.
Of course. Thank you for your time, and I'm glad you enjoyed it.